Hey guys, welcome to another online math class. This video will be about applications of linear programming, and by the end of this lesson we should be able to identify the constraints, be able to find the objective functions, and also be able to solve a maximizing and minimizing problem. Let's just pause the video here and take a couple of minutes to write these down. So we are coming towards the end of this topic, so we should now be able to apply linear programming to real-world applications. So let's have a go at solving some real-life problems that real businesses and companies often do come across. So there's a question here about a chocolate manufacturer. Just pause the video here, just take a couple of moments to read this question in detail and just unpause it when you're ready to go through the question with me. Alright, so overall this company manufactures two types of chocolates. One's called House Brand and the other's called Orange Delights. And the table below shows how much of each ingredient is required to make a type of chocolate. So to make the House Brand chocolate, the manufacturer needs 0.3 kilograms of chocolate and 0.7 kilograms of orange fill, whereas to make the Orange Delight they need 0.5 kilograms of both. The table also shows how much of each ingredient is available to them in a day. So in one day there's 300 kilograms of chocolate available and 350 kilograms of orange fill available. And the second table shows how much profit is made from each type of chocolate. And overall the question asks how much of each type of chocolate should be made to maximize profit. Alright, so our first step here is going to be to define the variables. So we're trying to find out how many kilograms of House Brand and Orange Delight should be made. So we need to use variables or different letters for those. So House Brand, let's say, let House Brand, let's just use X and Y, be X, and let Orange Delight be Y. So you could really pick any two letters, but it's just easier to use X and Y, especially with the calculator. And that's the variables defined in a little bit more detail. I'll just include that it refers to the amount and that the units is in kilograms. So now that we've defined the two variables, we now need to identify the different constraints. So most of the time you're always going to have these two constraints. First one being X has to be greater or equal to 0 and Y has to be greater or equal to 0. This because we can't have a negative amount of House Brand or Orange Delight chocolate. So you might find these two constraints are used pretty often. Our next constraint is going to refer to how much chocolate we have available, and the last one is going to refer to how much orange fill we have available. So we only have 300 kilograms of chocolate available. So that means we have to use exactly 300 or something less than 300. And each House Brand chocolate uses 0.3 kilograms. So it'll be 0.3x, and each Orange Delight uses 0.5. So we're going to do 0.3x plus 0.5. When you add those two together, 0.5y, sorry, that has to be either equal to or smaller than 300. And for our last constraint, has to be smaller or equal to 350. That's because we only have 350 kilograms of orange fill every day. And so for each House Brand chocolate, it uses 0.7 kilograms, whereas for Orange Delight, it uses 0.5 kilograms. So I've got a total of 4 constraints there. So once you've got the constraints, you can now identify the feasible region. And we're going to need to do this to identify the different corner points. So to help you do this, just get your CAS calculators out. And remember, when we're doing this on the CAS, we want to start off by making Y the subject. So that involves using the solve function. And that's what your CAS calculator should look like. Just let me know if you forgot how to do this. And press enter and you'll get that. And we're going to do the same thing for the next one too. And that's what your calculator should look like. Just press enter and you'll get the last one as well. Once we're here, we're able to graph these onto our calculators. Just press this one here and press that and you'll get the bunch of equations there. This is from the other day, so I'm just going to clear all of those. And if your calculator is in terms of X like mine is right now, make sure you just change it to Y. So click that drop down arrow and make sure you click the right one. We're after this one first. So our first one is Y is greater or equal to 0, so just type in 0. And it should change that for you. There we go. And this next one, we can see that Y is smaller or equal to, so I now need to change that again. Just press the other one and just copy and paste that equation. Just highlight that and copy that straight over. Same with the one below. So don't type it in, just highlight it and drag it down. And our last one is in terms of X, so make sure you change that, and that's X is greater or equal to 0. So just click that one there and type 0. Once you've done that, just make sure all the boxes are ticked. Now that we've got that, we've got to graph it. Just click that top left button there and it should graph that for you. But we can't quite see the graph just yet. That's because our graph is outside this axis. So we need to play around with the zoom. Just go to zoom, zoom out, and you'll start to see the graph a bit. And this is way too zoomed out, so you can't really see the values. So the best way to get a good image of the graph is to press zoom, box, and just click and drag the area you want to see. And there we go, that's much nicer. You might even want to do that one more time just so you get an even better image. So I'll just do that again, just like so, and that's even better. And remembering back to last lesson, remember we need the corner points of the feasible region to help us find either the maximum or the minimum values. In this case, we're after the maximum, but we'll get to that a bit later. So to find the corner points, start off by going to analysis, Gsolve, and just press intersection. And you can toggle between the different lines. Let's just start with that one, that's okay. Press exe, and then pick the next one. Let's go to the green one. There we go, and press exe. That gives me that point there. So draw out one of these tables, it will help you out. Might remember it from our last lesson. I'm just gonna make a bit more space under the objective function so I can write that in later. So our first point, if you go back to the calculator, was 0, 500. So let's just write that down below. So 0, 500. There was 500, 0, so I'll just change that up. And now let's find the other points too. So go back to analysis, Gsolve, intersection. Let's find it with that one and that one. The red one there, and that's 125, 525. So write that one in too. So we just need to find all the corner points. Another corner point, you won't need the calculator for this one. It's just 0, 0. That one down there, so write that one in. This one's a little bit different. Just press analysis, Gsolve, and y-intercept, and you'll get that once you toggle to the right one. So we're after the red one there. And there we go, it's 0, 600. And that's just a neater version of the table. Once we got the corner points, you could do this before this, but we need to find the objective function, and that's found using that table below. And the total profit is going to be 7.5 times the amount of house brand we make, so that's going to be X plus 10.00 times the amount of Orange Delight we make. I just use P for profit there. Alright, so we're going to substitute these values into my objective function, so that's going to be P equals 7.5 times 500 plus 10 times Y, so in this case 0, and just work that out using your calculator, and that first one will give you $3,750. Alright, so let's do that with the rest of them as well. So just substituting the values, so I said that'll be 7.5 times 125 plus 10 times 525. If you work that out, that will give you a value of 6,187.50. This next one will give you a value of $0, and this last one will give you a value of $3,750. So looking at this table, we can see the highest profit is $6,187.50 when X is 125 and Y is 525. So your final answer will be the maximum profit is $6,187.50, which is obtained by making 125 kilograms of house brand and 525 kilograms of Orange Delights. Alright, now let's move to another question. This one's to do with minimizing. Just pause the video and have a couple of minutes to read this question. So this question is very similar to the one before, except we're trying to minimize. So for healthy plant growth, apparently you need X, Y, Z nutrients, and to get that we need these materials. So to make nutrient X, we need 30 units of speed grow and 20 units of power feed, and you need at least 160 units of X. And for nutrient Y, you need 50 units of speed grow, 20 units of power feed, and we need at least 200 units of Y. And same deal with Z. So first step again, we need to define the different variables. So we're going to use X and Y again. We're going to say let X be the amount in kilograms of speed grow, and let Y, same deal, be the amount in kilogram of power feed. I'll just write that there. Now our constraints, once again, we can't have negative values here. We don't want negative amounts of speed grow or power feed. So our first set of limitations are going to be X is greater or equal to 0 and Y is greater or equal to 0. So we're going to need at least 160 units of X here. So that means it needs to be greater or equal to 160. So that means the amount of materials must be greater than that. So that needs to be 30 x plus 20y here, just got from that table. Next one, same deal, I'll just fill out the rest. I need at least or more than 200 units of y, and to get that we need to use at least this much materials, and same with z. There we go, they're your set of constraints there. Right, now using those inequalities, we need to set up our graph again to find the feasible region, so just clear everything here. So once again, I'm going to start off by making all of these in terms of y. And there we go, just use the solve function for that. So that's the bottom three there. Now we need to copy them over to the graph. So just click on that. There we go. And remember, we want the left-hand side to be greater or equals to. So just change that to there and just copy the functions over. Remember, from there. So I'll do it with that. So I've just gone ahead and filled in all the inequalities. Now press that graph function and you should start seeing a graph. Once again, playing around with the zoom function, it doesn't look too nice. I'm just going to move it over like that. And that looks okay. But I couldn't quite see all the intercepts, so I just used the quick standard function that seemed to work best for this graph. So if you want that, just go to zoom, quick standard, and you have something like that. I'm just going to move it over so I can see all the intercepts. Once you're here, you need to find the corner points. So you might want to get a table like that ready. So having a look, using the analysis, gsolve, the intersection and the y-intercept, find all the corner points of the feasible region. So you should have a total of 1, 2, 3, 4 corner points. And if you found them correctly, these are your corner points. Let me know if you had trouble with that. And then write the objective function up the top, which is going to be cost equals 8x plus 6y. And then substitute these values into there to work them out. And these are the values you should get once you've worked it out correctly. And so your final answer should be something along the lines of the minimum cost is $44, which is achieved by buying 4 kilograms of speed grower and 2 kilograms of power feed. Alright, so that brings us to the end of this video. That was a long one. Thank you for bearing with me. And just remember, if you do need any more help, just please remember to ask me in the Google Meet or contact me via email. Otherwise, thank you guys for watching, and I'll see you guys all back online.